For this problem, we have f of x is equal to x minus 2 times sine of x for the interval between 0 and 2 pi. We are looking for the intervals in which our function is increasing. So the first thing we need to do is to come up with a plan. What we do know is that we need to go find f prime of x. Remember that the derivative of f of x gives me slopes, and so the slopes will tell me if they're increasing or decreasing. After that, we're going to find out when f prime of x is equal to 0. This will give me some x values of our critical points. So we know that our graph is neither increasing or decreasing at that point, but either before or after it may be increasing or decreasing. The third thing we're going to do is we're going to put those x values between 0 and 2 pi on a number line, and what it does, it's going to break up our interval into pieces, into sub-intervals. And what we want to do is we want to know what happens between 0 and our first value. So we're going to test points in that interval, and we're going to test another one in our next interval, and then we're going to test it for the last one, which will be x of 2 to 2 pi. So that's going to be our guys. They shouldn't have equal signs, since we know that if it's equal to x sub 1 or x sub 2, then our slope is equal to 0. So because those are our x values that we found up here. So we're going to test points in the intervals, or the subintervals that we found. And we're going to apply that if we find f prime of x of our test point is greater than 0, then that whole interval is increasing. And if it's less than 0, then that whole interval is decreasing. And that's how we're finding what we're asking to be found. So the first thing we need to do is to find f prime of x. And that's going to give us 1 minus 2 times cosine of x. So that's the first thing we need to do. The second thing we needed to do is to get our f prime of x and set it equal to 0. So we're going to get 1 minus 2 cosine of x equal to 0. So remember, we're going to be solving for cosine of x. So I'm going to have negative 2 cosine of x is equal to negative 1. I'm going to divide both sides by negative 2. And I'm going to find that cosine of x is equal to 1/2. Remember, we can also go further and say that x is equal to the inverse cosine of 1/2. I am, however, going to use this fact in our unit circle to find the x values in which that occurs. So we want to know when cosine is equal to 1/2. At pi over 3, we have the values 1/2 square root of 3 over 2. And we're in particularly looking at the 1/2 for cosine. So now we're going to see that it also happens again down here at 5 pi over 3, because that one's going to be 1/2 and a negative square root of 3 over 2. And again, remember, we're only looking for the cosine, and we want cosine to be 1/2. So now we have found our two x values. We found that x can equal to pi over 3, and that x can equal to 5 pi over 3. So remember, we're going to put this on our number line between 0 and 2 pi, and that's going to break up our number line into 3 sections, which means we need 3 numbers. We need a number between 0 and pi over 3. We need a number between pi over 3 and 5 pi over 3. And we need a number between 5 pi over 3 and 2 pi. And those are going to be our test points. So now let's select a point between 0 and pi over 3. I know that pi over 6 is in between those two. Between pi over 3 and 5 pi over 3, I know pi is in between there. And between 5 pi over 3 and 2 pi, I know that 11 pi over 6 is in there. Now, how do I know those are in there? Remember our unit circle. We know that this is 0, this is pi, and over here is 2 pi. We know that we have pi over 3, so I know I need to find something in between 0 and pi over 3. I could have easily picked pi over 4, but I also know that pi over 6 is here. And I also know that I need to pick something between pi over 3 and 5 pi over 3, somewhere in between here, and that's why I picked pi. And then the last one we need to pick is some number between 5 pi over 3 and 2 pi. So I know that 11 pi over 6 is in there. So that's where those points came from. So let's test those points. So we are now going to plug in f prime of pi over 6. We're going to plug in pi over 6 into f prime. Remember that's going to be 1 minus 2 cosine of pi over 6. That's going to be 1 minus 2 times cosine of pi over 6 is the square root of 3 over 2. And that's going to be 1 minus the square root of 3. Remember, I'm multiplying fractions. And we're going to see that this number is going to be some number less than 0 because the square root of 3 is 1 point something. So I have 1 minus 1 point something. That's going to give me a negative number. So we know that from 0 to pi over 3, that at that interval it is decreasing because we have a number less than 0. So now let's try f prime with pi in it. So it's going to be 1 minus 2 times cosine of pi. That's 1 minus 2 times cosine of pi is negative 1. So it's going to be 1 plus 2, which we can see is greater than 0. So we know that between pi over 3 and 5 pi over 3, that interval is increasing because we got a number greater than 0. Lastly, let's find f prime of 11 pi over 6. Remember, that's 1 minus 2 times cosine of 11 pi over 6. Be 1 minus 2 cosine of 11 pi over 6 is the square root of 3 over 2. And we can see that's going to be 1 minus the square root of 3, which is less than 0. That means between 5 pi over 6 and 2 pi, that interval is decreasing. So we have found the intervals that are increasing and decreasing. And that concludes this video.